Okay, 5-7 is about polygons in the coordinate plane. And notice it says day 1. We're going to spend more than 1 day on this. Okay, so this section is really going to bring in a bunch of different things that we've talked about so far. It's going to bring in all the polygons that we talked about and what's special about them. And it's going to bring back the distance formula, the midpoint formula, the slope formula. We're going to talk about negative reciprocal slopes for lines being perpendicular. So it's going to bring in a lot of information. So there's literally going to be only 3 problems in this entire video, but it's going to take us a little bit to get through all 3. Okay, so what you're looking at now, again, is just formulas on the coordinate plane that you've seen before. So the first one that we have is the distance formula, which again is D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. When would you use the distance formula in the coordinate plane? Again, coordinate plane is on a graph to determine if your sides are congruent or diagonals are congruent. Then we also talked about the midpoint formula. Midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. When would you use the midpoint formula in this section? To determine the midpoint of a side and whether diagonals bisect each other. If they bisect each other, they're going to share that same midpoint. And your slope formula. Slope formula, again, is m equals y1 minus y2 over x1 minus x2. And when would you use the slope? To determine whether opposite sides are parallel. Remember, parallel lines have equal slopes, and that's written on the bottom here. Okay, parallel lines have equal slopes, the same slopes. And if lines are going to be perpendicular, perpendicular would have negative reciprocal slopes. Remember what that means. One has to be positive, one has to be negative, and again, they're the flip of each other. So if you started with 3 over 2, the negative reciprocal of that, if 3 over 2 is positive, next one has to be negative, flip 3 over 2, and it would become 2 over 3. So these two things are negative reciprocals. So again, you can show whether something is perpendicular. So in this case, we can show if diagonals are perpendicular, or maybe if we wanted to show that something was a square, we could show that we had a right angle. So here's the criteria that we're going to use. Okay, we're going to be asked to show that maybe something is a right triangle, an isosceles triangle, an equilateral triangle, all this stuff written down the left-hand side. So here's what we're going to have to show. So if you want to show that something is a right triangle, what do you need? You need a right angle. So what are you going to have to do? How are you going to find a right angle? You're going to use the slope formula. Okay, so and you're going to have to use the slope formula 2 times. If you can show that there's a right angle, then you're going to have a right triangle. For an isosceles triangle, you're going to have to show that 2 sides are congruent, okay? Which means you're going to have to use the distance formula not twice. You have to use it 3 times. Why? Because you want to show that 2 sides are congruent and the 3rd side is not. So you have to use it 3 times for the isosceles triangle. And then for the equilateral triangle, you would do the same exact thing. You want to show that all 3 sides are congruent. So again, you'd need to use the distance formula 3 times. But again, all 3 times that you use it, it should come out to be the same answer. A scalene triangle, again, a scalene triangle by definition has no congruent sides. So we're going to use the distance formula 3 times, and we're going to get 3 different answers. Let's say that you wanted to show that something was a parallelogram. What you'd need to show is that opposite sides are congruent. So you have 2 pairs of opposite sides, and you have diagonals are not congruent. So you'd have to show those 2 distances are different. So 2 pairs of opposite sides are congruent. Real rough here. Sorry, that's more of a rectangle. But you have to show one side equal to the other side, that side equal to that side. So that's the distance 4 times. And then you're going to have to show the diagonals are not congruent. So you need to use the distance formula 6 times to show that something is a parallelogram. Rectangle is opposite sides are congruent and the diagonals are congruent as well. So literally this is just like number 5 with the parallelogram, except when you use the distance formula, again, this time you want the diagonals to be congruent instead of not congruent. A rhombus, you have to show that all the sides are congruent and the diagonals are not congruent. A rhombus has 4 sides, so that's the distance formula 4 times. And then the diagonals are not congruent. That would be an additional 2 times. So again, we're going to need to use the distance formula 6 times. A square. All sides are equal, and the diagonals are congruent. Once again, distance formula 6 times. Square has 4 sides, 2 diagonals, distance 6 times. Trapezoid, you have to show 1 pair of parallel sides. Hey, that doesn't mean that you just use the slope formula twice and show that you have a pair of parallel sides. You have to show that you have a pair that's parallel and then the other pair is not parallel. So you're going to have to use the slope formula 4 times. And an isosceles trapezoid, only 1 pair of parallel sides and the legs are congruent. So just like with the trapezoid, the first thing that you're going to have to do is use the slope formula 4 times to show you have the 1 pair of parallel sides and that the other pair is not. And then you'll need to use the distance formula 2 times to get your non-parallel sides congruent. Okay, so here we go with example number 1. So the vertices of triangle ABC are 1, 1, 3, 8, and -1, 8. And we want to show that triangle ABC is an isosceles triangle. So again, if you look back into that chart that we just scrolled through, this means I'm going to need to use the distance formula 3 times. Again, I want to show it's isosceles, so 2 sides have to be equal. But again, I'm going to show that the third one is not. So I'm just going to, again, graph this so I know what I'm looking at here. A is 1, 1. B is 3, 2, 3, 4, 5, 6, 7, 8. B is here. And C is -1, 8, which will be there. Just so we have an idea of what's going on. Okay, so the first thing that I'm going to do is I'm going to find the length of side AB. Okay, so I need to find the distance of AB. And again, just because it's the first time that we're using this in a while, I'm just going to rewrite that distance formula. It's x1 minus x2 squared plus y1 minus y2 squared. Okay, so again, doesn't matter which one I call x1, y1 and which one I call x2, y2, but I'm only using the coordinates a and b, so I'm ignoring coordinate c right now. So I'll call this x1, y1 and this one x2, y2. Okay, so x1 is 1. You have a minus sign from the formula. x2 is 3. y1 is 1. You have a minus sign from the formula, and y2 is 8. Okay, subtracting 1 minus 3 is going to give you an answer of -2. So we'll have -2 squared, and 1 minus 8 is going to be a -7. So we'll have -7 squared there. -2 squared is a +4, and -7 squared is a +49. And when I add them together, I'll have the square root of 53. Okay, it doesn't say anything about leaving something in radical form or not, so I'm just going to leave it. I'm not going to do any extra work. This problem's going to take long enough already. I don't need to make it longer. So the length of side AB is radical 53. Okay, again, doesn't matter which side we find the distance of next. How about side AC? So now I want to find the distance of AC. So we're going to use the same formula, and just to save time, since it's already written above, I'm not going to rewrite it, but this time I'm using A and C. So I'll keep consistent here with my colors. So A will be my x1, y1. Again, we're ignoring B this time. And C will be x2, y2. Okay, so x1 is 1. Minus sign from the formula. x2 is -1. So you have 1 minus -1 squared for your first one. And your second one, y1 minus y2, it's going to be 1 minus 8. And we need to square that. Hey, again, just be careful. Use your calculator to help you. No sense in getting something wrong because you can't add or subtract correctly. That's going to be a keep, change. So that's going to be 2 squared. And then the other one, 1 minus 8 is going to be a -7. 2 squared is +4. Should be squared here, sorry. Negative 7 squared is a positive 49. And again, if I add 49 and 4, that means I have the square root of 53, which means now side AC is 53. So again, so far I have two sides that are equal, but again, I need to now show that the third side is not the same, because if the third side is the same, it's not isosceles, then it would be equilateral. So how about blue for the third side? So now I need the distance of CB. Okay, so again, my formula is already written. This time, again, I'm ignoring the coordinate of A, and I'm talking about B and C. So I'll call this one x1, y1, and this one x2, y2. So x1 is 3 minus negative 1. So I'm going to have 3 minus negative 1 squared plus 8 minus 8 squared. Hey, again, just be careful. Add the opposite. So I'm going to end up with 4 squared, and 8 minus 8 is 0 plus 0 squared. 4 squared is 16, and 0 squared is just going to be 0. We can get rid of that. Since 16 is a perfect square, I will take the square root of it. It's 4, so the distance of your third side is 4. Okay, so now we've done all this work. We just need to make sure that we state why this is isosceles in the end. Okay, again, isosceles triangle has two congruent sides. So triangle ABC is isosceles because AB is congruent to AC. And now you've shown that that's an isosceles triangle. For 2, we want to show that quadrilateral DEFG with those coordinates is a rectangle. So again, easiest thing to do here is to draw the triangle first. So 0, 2 is there. 1, 2, 3, 4, 5, 6, 7, 8. The EF is 7, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6. F and G, 1, 2, 3, 0. I don't think I could have drawn a better rectangle if I tried. Okay, so to show that this is a rectangle, again, if you scrolled back up, this means that we're going to need to use the distance formula 6 times. Why? Again, I have to show that both pairs of opposite sides are congruent. So I have to show that EF is congruent to DG. So that's distance twice. And then I have to show DE is congruent to GF. Again, that's another 2 times. So we're up to 4 times. And then I need to show that the diagonals are congruent. So I would need to show that DF is congruent to EG. And again, that's going to be the distance formula another 2 times. So altogether 6 times, both pairs of opposite sides congruent, and then the diagonals are congruent. That's why we're using it 6 times. Again, it doesn't matter where you start. I'm going to start with DE. Okay, so I'm concentrating on the coordinates of D and E, which means I'm ignoring F and G. X1, Y1, X2, Y2. Again, since we're starting a new slide here, I'll rewrite that distance formula another time for you. X1 minus X2 squared plus Y1 minus Y2 squared. There go my dogs. Oi. It's just FedEx. It's Christmas time. Christmas packages are being delivered. I'm not stopping this because I can't restart. Okay, so again, labeled X1, Y1, X2, Y2. So again, as quick as they start, they stop. X1 is 0, minus X2 is 4. So 0 minus 4 squared, plus Y1 is 2, minus Y2 is 8. And again, I need to square that. 0 minus 4 is negative 4, so we'll have negative 4 squared. And then 2 minus 8 will be a negative 6, so we'll have negative 6 squared. Okay, negative 4 squared is a positive 16, and negative 6 squared is a positive 36. And when I add 16 plus 36, I should get an answer of 52. And just like on that last slide, we'll leave it as radical 52. So what I've just showed is that this side, the distance is radical 52. So why don't we stick with the pair that's opposite that to get that radical 52 again. So let's find the distance of GF next. So for GF, okay, this time I'm ignoring D and E, and I'm using G and F only. So ignore D, ignore E, and again we're using F and G. And again, that's that's X1, Y1, X2, Y2. Again, the distance formula is written above, so I'm not going to rewrite it right now. Hey, I'm just going to start plugging in. X1 is 7. You have a minus sign from the formula, and X2 is 3. So I'm going to have 7 minus 3 squared, plus Y1 is 6. Minus sign from the formula, and Y2 is 0, so 6 minus 0 squared. 7 minus 3 is 4, so I'm going to have 4 squared, and 6 minus 0 is 6, so we'll have 6 squared. Again, positive 4 squared is a positive 16, and positive 6 squared is a positive 36, and 16 plus 36 is 52. So I've shown now that this side is also radical 52. So far, after all that work, I have one pair of opposite sides that are parallel. Let's keep going. Let's do the other pair of sides. Again, doesn't matter which one of those pairs, which one of those sides you do first. How about we'll do side DG. So let's do the distance of DG. Okay, so again, this time I am ignoring E and F, and I'm using D and G. So we'll have our X1, Y1, X2, Y2. So X1 minus X2, 0 minus 3 squared, plus Y1 minus Y2, 2 minus 0 squared. Okay, again, when I do my subtraction there, 0 minus 3 is negative 3, and 2 minus 0 will be positive 2. If you're using your calculator to help you square, again, when you have a negative number, pretty please with sugar on top, make sure that you put it inside a set of parentheses, or your calculator is going to give you a wrong answer. Negative 3 squared is a positive 9, and positive 2 squared is a positive 4. And 9 plus 4 is 13. So DG is radical 13. Hey, we're getting there. Next thing that we have to find, let's find the side that's opposite that. Let's find EF. So again, with EF, I'm going to ignore the other coordinates. Running out of colors to use here. How about black? So I'm using E and F, and I'm ignoring D and G. So we'll do X1, Y1, not X1, Y2. X1, Y1, X2, Y2. So this is going to be the distance of EF now. Okay, so X1 is 4 minus X2 is 7. So I'm going to have 4 minus 7 squared plus Y1 is 8 minus Y2 is 6. So 8 minus 6 squared. 4 minus 7 is going to be a negative 3. So we'll have negative 3 squared. And 8 minus 6 is going to be a -2, and we're going to square that. -3 squared is a +9. -2 squared is a +4. And 9 plus 4 is 13. So again, my other side is the square root of 13. Okay, so far, again, we've used the distance formula 4 times. And now what we've shown is we have both pairs of opposite sides that are congruent. But I don't know if that's a parallelogram then or a rectangle. So now we have to talk about our diagonals. So now if I can show my diagonals are congruent, that's going to actually make it a rectangle instead of a parallelogram. So for my first set of diagonals, I'm going to do EG first. Okay, so I'm going to do EG first, which means we'll do EG in green. Hey, I'm ignoring D and I'm ignoring F. So I'm going to do X1, Y1, X2, Y2. Okay, again, I'm going to scroll down. You can obviously, you have the coordinates right there. I can see them on my paper too. So I don't want to write on the graph grid over on the right because I feel like it's going to get too messy. Okay, so we're doing EG. Again, we're doing X1 minus X2. So we're going to have 4 minus 3 squared plus 8 minus 0 squared. 4 minus 3 is 1, so I'm going to have 1 squared, and 8 minus 0 is 8, so I'll have 8 squared. 1 squared is 1. 8 squared is 64. So we're going to have the square root of 1 plus 64, but when I add 1 and 64, I'll get an answer of the square root of 65. So the length of one of the diagonals is the square root of 65. And now last but not least, I am going to find DF. Okay, so this time around, gray? How about gray? This time around again, I want to find DF, which means I'm ignoring E and G. So this time around, I'm going to have X1, Y1, and X2, Y2. Again, I'll scroll down and I'll write it right to that right. Again, you can still see the coordinates on your piece of paper. Okay, so this is the distance of DF. So again, we're doing X1 minus X2. So 0 minus 7 squared. A plus sign from the formula itself, and then 2 minus 6 squared. 0 minus 7 is -7, so I'll have -7 squared. And 2 minus 6 is -4, so we'll have -4 squared. -7 squared is a +49, and -4 squared is a +16, and 49 plus 16 equals 65. So your other diagonal equals 65. So after all of that tedious work, you've now shown that this is a rectangle. Why? Because both pairs of opposite sides are congruent and the diagonals are congruent. So I'm just going to state that before we go on to the last problem. So D, E, F, G is a rectangle. Again, that's because both pairs of opposite sides are congruent and the diagonals are congruent. Again, if the diagonals weren't congruent, then that would have made it a parallelogram.